Well, hey there, sport. How you doing today? I thought we could read ourselves a nice, good book. We've got The Environments Out There by Isaac Asimov. He's a great author. So we'll just jump right up. We'll skip the foreword. That's okay. We like to hear what Isaac has to say himself, not what other people get to say for him or about him. The first stop in space. The moon is located in the Earth's neighborhood, only 250,000 miles away. It's just as far from the sun as Earth is. Both worlds get just the same quantity of heat and light. Yet, despite these similarities, the moon is not at all like the Earth. Our world is full of life. The moon is dead. Oh, it's a bit of an exaggeration. It's a small world. The chief trouble with the moon as an environment for life is its smallness. The diameter is only about 2,160 miles, about the distance from New York City to Phoenix, Arizona. It has a surface area of 14 million square miles, which is smaller than that of North and South America taken together. It's less than an 80th as massive as the Earth. Since the moon is such a small world, its gravitational force is small too. The moon's gravity is only about 1/6 of that of the Earth. Let's go ahead and fix our hair just a little bit, buddy. What a tremendous difference that makes. An atmosphere is held to a planet by the force of gravity. The Earth's gravity is strong enough to hold an atmosphere, but the moon is not. So, there's no moon air. You can see a nice picture of the moon right here. In the absence of air, water turns to vapor, and the moon's gravity is not able to hold it. It leaks out into space. So, the moon has no water either. It's a silent world. Since life as we know it cannot develop without water, it seems certain that the moon is a dead world. There is a chance that in some of the out-of-the-way places, in the shadows of crater walls, perhaps traces of water and air may linger. In 1969, astronauts landed on the moon and brought back rocks from its surface. These rocks showed no traces of water or life, but, of course, there are many other places to explore on the moon. Nor were they able to get samples of rock from several feet below the surface. Meanwhile, astronomers are insisting that any objects sent out to land on the moon be completely sterilized. We don't want to infect the moon's surface with earthly life before we have investigated or discovered whatever native life may exist there. The absence of air makes for a strange and even dangerous world. Air carries sound, for example. Without air, the moon is a silent world, and moon explorers will feel as though they were watching a television screen with the sound turned off, although they will hear each other on the radio and will detect vibrations carried through the ground beneath their feet. Air absorbs and scatters light, and the moon's atmosphere is different than that of Earth because Earth has a protective blanket against radiation. On the moon, the sun's light blazes down unsoftened by air, and is full of strong ultraviolet and even X-rays. There are electrons and other particles shot out by the sun and cosmic ray particles from outer space. Moon explorers will have to guard against this hard radiation at all times. They'll probably be able to step out into direct sunlight for only a few moments. Even then, their transparent face masks will have to be composed of special substances that will even cut out hard radiation. Now, there is a meteor hazard. An atmosphere also serves as protection against meteors. These are rock bodies ranging from some that weigh dozens of tons to trillions of micrometers that are no bigger than tiny dust particles. Space in the neighborhood of the Earth and the Moon is just full of them. When we headed towards Earth, meteors heat up as they plow through the upper atmosphere. The reason? Friction between the meteor and the atmosphere. They melt and they glow, and we call them shooting stars when we see them. Almost all meteors melt away completely long before they even reach the Earth's surface. Only a few of the very largest meteors can hit the ground, and these are called meteorites when they strike the ground. On the airless moon, all of the meteors that strike the moon's surface, silently and coldly, but with tremendous impact. These may be dangerous to the moon explorers. Even a small meteorite can puncture a spacesuit and produce a leak, then hit the man inside, too. Perhaps explorers will have to move about with metal umbrellas that will slow up all small meteors to the point where they bounce off the spacesuit instead of penetrating it. In the youth of the solar system, there were many more meteors, especially the large ones, drifting through space. It's believed that these collided with the moon's surface, and they left these circular craters, some of which are more than 100 miles across. There are many thousands of these craters all across the moon's surface, as well as many Earth-like mountain ranges to the moon. To explorers of the moon's surface, however, the craters and the mountains won't seem very impressive, because they slope rather gently. Moreover, they'll be pretty easy to climb, for an explorer will be much lighter than he would be on Earth, thanks to the moon's weak gravity. Even a massive spacesuit won't really slow him down much. Climbing a moon peak as high as Mount Everest, which is 2,928 feet, should take scarcely more physical effort than climbing Mount Washington, which is only 6,288 feet on Earth. Now, the Sea of the Moon. There are flat spots on the moon too, some circular plains that are more than 500 miles wide. These are called Maria, meaning seas in Latin, because early astronomers thought they were seas. The Maria may be the remains of enormous craters that were gouged out long ago by colossal meteors, and were then filled up with lava-like material. A moon explorer standing in the middle of a Maria, or the interior of one of the large craters, might not be aware of the surrounding high crater walls. Why? Well, since the moon is smaller than Earth, it curves a lot more sharply, and the horizon is a lot nearer or closer for your vision. If the explorer were in the center of a crater, then the distant crater walls might as well be below the near horizon. The explorer would see nothing but flatness, broken only by small pits, or craterlets made by smallish meteors. Curiously, the Maria and the large craters do not seem to be evenly distributed over the moon. At least, this is the evidence that we currently see. And you can see there's some great pictures of some of these craters that we're talking about. From photographs taken by the moon on the Soviet spacecraft Zond. And you can see here, we've got some more photos like that. Now, on the far side of the moon, the half of the moon that we never see from Earth, the Soviet photographs show both fewer Maria, or those flat plains, and fewer large craters. Now, why would that be? Astronomers aren't sure. Clearly, says one, the moon is trying to tell us something. Now, mystery surfaces. The flat surfaces on the moon may present a special danger. All the meteors striking the moon through billions of years may have pulverized the surface and created a layer of fine dust, many feet thick. A careless moon explorer might suddenly sink to their death, so it may be necessary for them to walk around on broad snowshoe-like boots to prevent this. But the dust layer theory is just one of many guesses about the moon's surface. Not even the 11,000 pictures taken by the TV cameras aboard the U.S. moon probes, Ranger 7 and 8 in 1964 and 1965, provided a final answer concerning the actual structure of the lunar terrain. After studying the Ranger pictures, one famous astronomer, a Dr. Gerard Kuiper, well, that's for later on, offered this description. A frothy surface... Right after I just said Kuiper, be better. A frothy surface like crunchy snow, which can hold many treacherous things. Are you even trying at this point? Another scientist, Nobel Prize winner Dr. Harold Urey, yes, my boy Urey Miller-Crick. Oh, abiogenesis created artificial compounds using non-existent monomers. I have a thing for Urey and Crick experiments, or the Urey Miller-Crick experiments. Anyway, holds to the dust layer theory. The dust could be 60 feet deep in most places, says Dr. Urey, but possibly there may be small exposed patches of harder material at the bottom of some craters. A great guessing game. Could it be that the moon's surface is all these things? Here, like crunchy snow, there, a dust layer over there. There, a dust layer over there, a hard, rocky highland? Well, that's written weirdly. A surveyor spacecraft soft landed its payload of instruments to the moon in 1966 and sent back magnificent information. In its place of landing, at least, the soil was pebbly and firm. Is it that way everywhere, they thought? The astronomers who walked on the moon in 1969 had no difficulty. They found the surface quite solid, though there was some dust on the surface which disturbed by the engines where they landed and which left clear footprints. Now, land of never gray. Dust or no dust, the moonscape will have a weird, forbidding beauty. Since there is no atmosphere to scatter light, the sky above the Moon Explorer will always be black, neither blue nor gray. No light will be scattered into shadows either. On the Earth, where shadows are gray, we can read comfortably in shadow by the scattered light of the sun. On the Moon, the shadows are pitch black. If a Moon Explorer steps beyond a boulder to get out of the sunlight, he will step into dark midnight, but perhaps not darkest midnight. Recent studies have indicated that the Moon's glow may not all be due to the reflected sunlight. There's a missing the there, but that's what it means. Apparently, some spots on the Moon are at least slightly luminescent. That is, they glow with the light of materials that emits light when hit by charged particles. The charged particles, of course, are part of the rain of radiation continually pouring out from the sun and are especially abundant when solar flares are at their peak. Perhaps, then, there will be patches and pinpoints of light to cheer the explorer in the darkness of the Moon. The view from the Moon. Without scattered lights, the stars will always be visible, even when the sun is bright in the sky. The sun may dazzle the Moon Explorer's eyes, if it is in their view, but if he, I'm adding or she, views the sky from a patch of shadow, he or she will see the stars. With no atmosphere to make starlight waver, the stars will not twinkle, but will shine steadily. Without clouds to obscure them or the air to dim them, there will be nearly twice as many stars visible in the moon sky as in our own, though the additional stars will be very dim. The stars will be arranged, of course, in the same familiar constellations they are visible on from Earth. To a man standing on the moon, the stars will appear to travel across the sky more slowly than they appear to do to a man on the Earth. Why? Because the moon rotates so slowly. The Earth's pull on the moon is so strong that it has slowed down the speed of the moon's rotation to the point where it stopped the rotation with respect to us. As a result, the moon always turns the same face towards the Earth as it makes its monthly revolution. As the moon circles the Earth, however, it presents each part of itself to the sun and to the stars. Thus, the moon has a day and night, each 2 weeks long. The sun and each star as well take 14 days to go from rising to setting. Without an atmosphere, of course, there is no dawn before sunrise and no twilight after sunset. With the sun steadily blazing down for 2 weeks, sunlit areas on the moon will reach a temperature equal to or above the boiling point of water. After the long 2-week night, the same spots may be 200 degrees below 0 Fahrenheit. However, these great temperature changes may be confined only to the very surface layer, for the dust and rocks of the moon's surface are poor heat conductors, another way of saying they are good thermal insulators. Thus, a few feet below the surface, the temperature may be quite mild and may stay the same through day and night. And you can see we've got a great picture here of the moon's atmosphere. What about the interior of the moon? Up until about 1965, it was almost an accepted scientific fact the moon's interior was cold and hard. Then, Soviet scientists revealed a study hinting that the moon's interior may be radioactive. Furthermore, hot radio waves from inside the moon indicated that the core is molten, not solid. If the observations are correct, that the core is molten, not solid, then this conclusion makes sense. A high level of radioactivity at the center of the moon would keep the core molten. Now, views of the Earth. Since the moon turns only one face to the Earth always stays in the same spot to the moon's sky. Because the moon travels in an eclipse and not a perfect circle, the Earth may seem to wobble just a little bit, and not in a perfect circle. The Earth may seem to wobble in a way that's just hardly noticeable. Over about 40% of the moon's surface, over about 40% of the moon's surface, the Earth is never visible. This is the far side of the moon that Soviet space probes photographed. I'm gonna pause this. Finally, over the remaining 20%, the Earth is located almost at the horizon, and because it seems to wobble, it sometimes dips below the horizon and sometimes rises above it. The Earth is a glorious sight as seen from the moon. It goes through phases just as the moon does to an Earth observer, but the Earth, when viewed from the moon, will be nearly 4 times as wide as the moon looks from Earth. The full Earth, as seen from the moon, will have about 13 times the surface of the full moon seen by us. What's more, since the Earth's atmosphere reflects far more sunlight than the moon's dull surface, the full Earth will be at least 80 times brighter than a full moon. The continents and oceans of the Earth won't be clearly visible from the moon. The Earth's atmosphere will scatter lights and form a bluish haze over the Earth, and white clouds will hide about half the globe. Thus, the Earth will be a big blue-white globe with ever-changing cloud formations. The swirling spiral of... And before we get there, I just want to show off a nice picture of a nice crescent moon that we have listed there from one of our lunar orbiters. Let's see, where were we? A swirling spiral of a traveling hurricane or typhoon may be visible at these times. You can see we've got an explorer here before we continue the next sentences. Look at that. As the sun slowly drifts across the moon's sky, it will usually pass above or below the globe of the Earth. Occasionally, however, it will pass behind the Earth and be eclipsed. On Earth, we see this as a lunar eclipse. Once the sun passes behind the Earth, the observer on the moon will see the atmosphere around the Earth glow orange-red with sunlight. The surface of the moon will turn a dull red. The globe of the Earth itself will be black. This might last for more than an hour until the sun... I had to pause again. He's still upstairs. Alright, I'm just going to read it. The globe of the Earth itself will be black. This might last for more than an hour until the sun again comes peeping out from behind the Earth to turn everything harsh black and white once more. Home on the moon. Now that men have landed on the moon, we can think about the next step. We may decide to set up a permanent moon colony under the surface. In a sealed underground cavern, air and microwave is currently on. The worst part is I have literally this, and that's it. Take 2, bud. In a sealed underground cavern, air and water may be collected. The solid material of the moon itself, lying between the cavern and the surface, will protect the colonists from radiation, meteors, heat, and cold. One scientist predicted that Moon's colonists will be able to tap the oxygen locked up in moon rocks. Some 45 pounds of rocks would yield 12 pounds of oxygen. Using this cavern as a base, explorers will venture onto the moon's surface. Within the cavern, it'll be almost like home, except for the gravity. A 150-pound man will weigh about 25 pounds. If he jumps, he'll soar 6 times as high and as far as he would be on the Earth. At the top of the jump, he'll be moving quite slowly, but by the time he reaches ground again, he'll be moving as quickly as the same jumping effort on Earth. With less gravity, moon explorers will also have to be contained with less friction, because they'll be pressing less hard against the floor. This means that everything a moon explorer walks on will seem more slippery than it would on Earth. Surfaces will have to be made particularly rough in order to increase friction, and men and women on the moon, yes, finally, gender pronouns, good for you, just say they. This was made in 1967. May take to wearing specifically weighted socks. There you go, get some Rock Lee on you. Even so, they'll have to practice walking and moving under light gravity if they are not to fall or bump at every step. The light gravity carries another danger with it. The muscles working against so much less weight may grow dangerously flabby. Explorers will probably have to exercise regularly. If they don't, they may never be able to return to Earth without great physical suffering, for when the moon explorers land once more on the Earth, the open air and blue skies may seem wonderful and a sight of grass and trees in cities like paradise. But unless they have kept fit, they will step from their spaceship and sink to their knees unable to fight the pull of Earth's gravity. Got a nice little lunar chart here. That's the end of chapter 1. I hope that everyone enjoyed.